Hi all, welcome to another session of Boilchem Tutor. In this session, I am discussing about the structure and bonding present in the Boron type clusters. The electron involved in the bonding of the Boron type clusters are termed as framework electrons or skeletal electrons. So let us look what all types of bonds are present in the Boron type clusters. There are actually 4 types of bonds are present, which are 3 center 2 electron BHB bond, and next is the 3 center 2 electron BBB bond, and next is 2 center 2 electron BB bond and 2 center 2 electron BH bond. So let us discuss each type of bond in detail. So first type of bond, that is 3 center 2 electron BHB bond. In 3 center 2 electron BHB bond means there are 3 atoms present in the BHB. That is why it is 3 center. Then 2 electron means only 2 electrons are involved in the bonding. How we can check? Because boron is having only 1 electron in the valence shell. Similarly, hydrogen also having 1 electron in the outermost shell. So each will share 1 electron and form a bond. But other boron atom is not involved in the bonding. Is not sharing any electron. That is why it is termed as 3 center 2 electron bond. And moreover, this BHB bond is having a bend-like structure. So the bond present in the BHB bond is otherwise termed as the banana bond, and that is a special type of a bond present in boranes. Coming to the next type of a bond, that is a 3 center 2 electron BBB bond. Here also there are 3 atoms, that is why 3 center. Again 2 electrons are involved in the bonding, that is why it is termed as 3 center 2 electron bond. Again in this BBB bond, there are 2 ways they can form the bond. One is the open way and other is the closed way. So these are the 2 ways in which BBB bond can present in the borane clusters. Coming to the third type of a bond, that is 2 center 2 electron BB bond. In 2 center 2 electron BB bond means there are 2 atoms are present, that is why it is termed as a 2 center, and each boron atom is having 1 electron in the valence shell. So they are involved in the sharing and therefore 2 electrons are involved in the bonding. Therefore it is having a normal linear like structure, that is BB bond. So coming to the last type of a bond, that is again 2 center 2 electron BH bond. Here also there are 2 atoms, that is why it is termed as a 2 center, and moreover each atom is having 1 electron in the valence shell and each are sharing 1 electron, and therefore total 2 electrons are involved in the bonding, and it also have a normal linear like structure. So the overall bonding of borane can be represented in the form of a 4-digit number, that is STYX number or STYX number. So let us discuss in detail what is S, what is T, what is Y and what is X in the STYX number. So S represents the number of 3 center 2 electron BHB bond. Again T represents the number of 3 center 2 electron BBB bond present in the borane, and which can be open and which can be closed. So how many total number of BBB bond are present, which represents the T in the STYX number. Then Y represents the number of 2 center 2 electron BB bond present in the boranes, and last X represents the number of BH2 groups in the boranes. So by knowing the STYX number, we can easily draw the structure of the borane type clusters. Moreover, there are some tricks to find out the STYX number of higher boranes. So let us discuss these tricks to find out the STYX number by taking an example of diborane, that is B2H6. So the first step involved in finding the STYX number of the borane is that we have to take the difference between the number of the hydrogen atom and number of boron atom present in that borane. And here in B2H6, the number of boron atom is 2 and number of hydrogen atom is 6. So when we are taking the difference, that is 6 minus 2, that become 4. In the second step, if the number of boron and hydrogen atom present in the borane are even means, then the difference obtained between the number of hydrogen and boron atom should also split up in terms of even number. Here the difference obtained is 4. So the 4 can be split in terms of even number as 2 plus 2. So in the third step, the splitted number, that is 4 is splitted as 2 plus 2. So this splitted number should be placed in the S and X of the STYX number. In the fourth step, we have to take the difference between the number of boron atom present in that borane and the S value present in the STYX number. Here the number of boron atom, then the diborane is 2 and S value obtained is 2. So if we are taking the difference, that is 2 minus 2 become 0. And this 0 will be equal to the T value in the STYX number. So in the last step, that is step 4th, we have to take the sum of S, T, Y and X in the STYX number, and this should be equal to the average of the number of boron atom and hydrogen atom present in that borane. So here in the diborane, S value obtained is 2 and T value obtained is 0 and Y value which didn't obtain, so we have to find out, so it should be kept as 1. Then X it is 2 and which will be equal to the number of boron atom present is 2 plus again hydrogen atom is 6, 6 divided by, it should be taken as an average, so 2 plus 6 divided by 2. So 2 plus 0 plus Y plus 2 is equal to 8 by 2, that will be equal to 4. So 4 plus Y is equal to 4 and Y should be equal to 0. So here the STYX number of diborane is 2002. So in diborane we found that the STYX number is 2002. So S represents the number of 3-center 2-electron BHB bond. That means in diborane 2 3-center 2-electron BHB bond are present. Again T represents the number of 3-center 2-electron BBB bond. Here the value obtained is 0. That means there is no 3-center 2-electron BBB bond. Again Y represents the number of 2-center 2-electron BB bond, and again the value obtained in diborane is 0. That means there is no 2-center 2-electron BB bond. Again last, X represents the number of BH2 groups. Here the X value obtained is 2. That means there are 2 number of BH2 groups. So the overall structure of diborane can be represented like this. Next we can find the STYX number of B4H10, that is tetraborane 10. So in the B4H10, the number of boron atom is 4 and number of hydrogen atom is 10. So first step is that taking the difference between the number of the hydrogen atom and the boron atom. So here the difference will be 10 minus 4, that will be equal to 6. So in the second step, here the number of boron atom is 4 and hydrogen atom number is 10. Both are even numbers. So the difference obtained between the number of hydrogen and the boron atom also should be split in terms of even number. So 6 can be split in terms of even number as 4 plus 2. In the third step, this 4 and 2, the splitted numbers are placed in S and X of the STYX number. And the fourth step is taking the difference between the number of boron atom present in the borane and the S value obtained from the STYX number. And here the number of boron atom is 4 and the S value obtained is 4. So taking the difference, it will be equal to 0 and that will be equal to the T value in the STYX number. And last step is the sum of S, T, Y and X in the STYX number, and this will be equal to the average of the number of boron atom and the hydrogen atom present in that borane. So here S value obtained is 4 and T value obtained is 0 and Y we have to find out, and X is obtained as 2. So 4 plus 0 plus Y plus 2 is equal to, average will be equal to 7 because 4 plus 10 divided by 2, that is equal to 7. So 6 plus Y is equal to 7, so Y will be equal to 1. So the STYX number of tetraborane 10, that is B4S10, is equal to 4012. So by getting the STYX number of B4S10, we can draw the structure of B4S10 like this. That is, there are 4 3-center 2-electron BHB bond, but there is no 3-center 2-electron BBB bond because we are getting the 0 as the T value. And then 1 represents the number of 2-center 2-electron BB bond. So there is 1 2 center 2 electron BB bond here. Again, there are 2 BH2 groups. So from the stick number, we can easily draw the structure of B4H10. Next, we can find the Stix number of B5H11, that is pentaborane 11. Here the number of boron atom is 5 and number of hydrogen atom is 11. So first step is taking the difference between the number of the hydrogen atom and the boron atom. So the difference will be 11 minus 5, that will be equal to 6. Here the number of boron atom and the hydrogen atom present in B5H11, that is odd numbers. So the difference obtained between the number of hydrogen atom and the boron atom also should be splitted in terms of odd numbers. So the difference is 6, so it can be splitted in terms of odd number, that is 3 plus 3. In the third step, that is these splitted numbers, that is 3 and 3 are placed in S and X of the Stix number. So in the fourth step, to get the T value, we are taking the difference between the number of the boron atom present in that borane and the S value obtained before. So when we take the difference, that is 5 minus 3, that will be equal to 2, and which is the T value of the Stix number. So in the last step, we are taking the sum of S, T, Y and X, and this will be equal to the average of the number of boron and hydrogen atom present in that borane. So here the S value obtained is 3 and T value obtained is 2, and Y we have to find out, and then X is equal to 3, and which is equal to the average, that is 5 plus 11 divided by 2. So here 3 plus 2 plus Y plus 3 is equal to 8. So 8 plus Y is equal to 8, so Y will be equal to 0. So the Stix number of B5H11 is 3203. So by getting the Stix number of B5H11, we can draw the structure of B5H11 like this. That is, there are 3 BHB bond, that is 3 center 2 electron BHB bond. Again, there are 2 3 center 2 electron BBB bond are present. Again, there is no 2 center 2 electron BB bond, but there are 3 BH2 unit. Next, we can find the Stix number of B6H10, that is hexaborane 10. Here the number of boron atom is 6 and hydrogen atom is 10. So when we are taking the difference, that is 10 minus 6, that will be equal to 4. Again, one important point to note is that if the compound of borane having boron atom 5 or more and the difference obtained between the number of boron atom and the hydrogen is 4 means we have to take that 4 as the S value and X value should be taken as 0, because we are splitting this 4 as 4 plus 0. So 4 should be taken as the S value and 0 as the X value. So in B6H10, we got S value as the 4 and 0 as the X value. And next step is taking the difference between the number of boron atom and the S value obtained. So here the number of boron atom is 6 minus S value is 4. So 6 minus 4, it is equal to 2, and that gives the T value in the Stix number. So last step is the taking the sum of S, T, Y and X, and which is equal to the average of the number of boron and the hydrogen atom present in that borane. So here S value obtained is 4 and T value obtained is 2, and Y we have to find out, and X is equal to 0. So we have to add as 4 plus 2 plus Y plus 0 is equal to, average will be equal to 8. So 4 plus 2, that is 6 plus Y is equal to 8. So Y will be equal to 2. So the Stix number of B6H10, that is hexaborane 10 is 4220. So by getting the Stix number, we can draw the structure of B6H10 like this. That is, there are 4 3 center 2 electron BHB bond. Again, there are 2 3 center 2 electron BBB bond. And there are 2 center 2 electron BB bond, and there is no BH2 groups. So the structure will be like this. Next, we can find the Stix number of B5H9, that is pentaborane 9. So here the number of boron atom is 5 and hydrogen atom is 9. So first step is taking the difference, that is 9 minus 5, that will be equal to 4. So here also the compound contain boron atom 5 and the difference obtained is 4. So we have to take the 4 as the S value and 0 as the X value. So 4 can be split as 4 plus 0 and 4 should be S value and 0 should be X value. Next step is taking the difference between the number of the boron atom present in that borane and the S value obtained. So here the number of boron atom is 5 and S value obtained is 4. So taking the difference we are getting 1 and which is equal to the T value in the STYX number. So last step is taking the sum of S, T, Y and X and which is equal to the average of the number of boron and hydrogen atom present in that borane. So here the S value obtained is 4 and T value obtained is 1 plus Y plus again 0 is the X number and which is equal to the average means here 5 plus 9 by 2 that will be equal to 7. So here 4 plus 1 plus Y plus 0 is equal to 7. So Y value is equal to 7 minus 5 that will be equal to 2. So the STYX number obtained for B5H9 is 4120. So by getting the STYX number of B5H9, we can draw the structure of B5H9 as follows. That is 4 represents the number of 3 center 2 electron BHB bond. Again 1 which represents the number of 3 center 2 electron BBB bond. And again 2 represents the number of 2 center 2 electron BB bond and 0 represents the number of BH2 groups. So here there is no BH2 groups and the structure can be like this. Next is to find the STYX number of B10H14 that is decaborane 14. So here the number of boron atom is 10 and the hydrogen atom is 14. So when we are taking the difference that is 14 minus 10 that is equal to 4. Again we found that for a compound of borane having boron atom more than 5 or 5 and the difference obtained is 4 means we have to take the 4 as the S value and 0 as the X value. So 4 can be split as 4 plus 0 and 4 will be the S and 0 will be the X value. Next is taking the difference between the number of the boron atom present in that B10H14 and the S value obtained. So here the number of boron atom is 10. 10 minus again S value obtained is 4 that will be equal to 6. So which gives the T in the STYX number. Next step is taking the sum of S, T, Y and X and which will be equal to the average of the number of boron atom and the hydrogen atom present in that borane. So here the S value obtained is 4 and T value obtained is 6 and Y we have to find out and X is 0. So 4 plus 6 plus Y plus 0 is equal to average will be 10 plus 14 by 2 that is equal to 12. So here Y value is equal to 12 minus 10 that will be equal to 2. So the STYX number of B10H14 is 4620. So by getting the STYX number of B10H14 we can draw the structure like this. That is there are 4 3 center 2 electron BHP bond and there are 6 3 center 2 electron BBB bond and out of that 2 are open like structure and rest 4 are closed like structure and there are 2 center 2 electron BB bond and again there is no BH2 units. So that is all in this session. Hope you like this session. Stay tuned for the next session. Till then, bye.